Hi there, welcome back. In today's video we are going to cover 3 chapters. The first chapter we are going to install Kubernetes K3s in our Proxmox server. In the second chapter we are going to deploy Nginx using 3 manifests. This is the best way to deploy Nginx in a Kubernetes cluster. And in the third chapter, we are going to do the workshop. If you're only interested in the workshop, just open the third chapter. Otherwise, you can go through each chapter according to what you require. In this video, we are going to answer 2 questions. As a DevOps, I have Docker skills. However, my Kubernetes skills are more valuable in the industry. This is something you need to consider for your career. Or if you are about to start a career in DevOps, this is definitely something you need to give consideration to, and we trust this video is going to help you. You may ask, why is Kubernetes more valuable than Docker in the industry? Well, I have 3 points to give you. First of all, the industry has adopted Kubernetes as the standard for cloud-native applications. Secondly, Kubernetes is production-ready. It offers load balancing, self-healing, and networking. And thirdly, Kubernetes provides us with scalability and orchestration. Kubernetes automates container deployments, scaling, and management. And then we answer, why is Kubernetes skills more valuable than Docker skills? Because Kubernetes goes beyond single containers, managing and orchestrating multiple containers across clusters. Secondly, there is an enterprise demand for Kubernetes, as most companies prioritize Kubernetes for scaling cloud-native deployments. Thirdly, Kubernetes provides a full ecosystem control, handling networking, storage, scaling, and self-healing. Enough said, let's start the workshop. We have provided a blog page with instructions for this video. Please have a look down below and find the link. We start in our Proxmox server. We have created 2 VM servers. We are going to follow this article in our GitHub repository to create the 2 Kubernetes nodes. What we want to do is we want to create a 2-node cluster with a primary node and a worker node. We have provided a link to this GitHub page down below as well. In our Proxmox server, we have created 2 VMs, one called master node and the other one called worker node. We will now SSH to the master node VM. I'm just adjusting this. Let's clear the screen. We need to run the sudo command so that we can do certain operations as root. Right, we are going to create a folder to keep the shell script that we are going to use to create the master node in the Kubernetes cluster. So let's make the directory. If you look in here, you will see the instructions that we need to run. These are the instructions we are going to run. We need to open the OPT folder and then the K3s folder. Now that we have created this folder, we need to go to our Git repository, find the link down below. We want this file, so click on the file, click on raw copy. And now we will create that shell script. Paste the content in here. Control S to save, X to exit. And then we need to make this executable. So this is the command that will make this executable. And now we need to run this. Let's first see that it is executable. And we can see it is executable there. So now we can run this shell script. It is going to GitHub repository and it's going to pull down the K3s Kubernetes, install it, and create us our master node. This is the primary master node of the Kubernetes cluster. We only run this shell script once, and then we use the other shell scripts. And you can see here we have put a command there. Please run this command to get the token. So here's the command. We need to use sudo for this command. Now we will copy this security token and we will paste it into a notepad. The first thing we want to do is we want to see if there's a Kubernetes cluster. So we are going to run the command kubectl get nodes. And you can see we have the master node. Now we will park this terminal and we'll open up a new one to connect to the other VM. We will now create the worker node. We are going to SSH to that server. Unfortunately, I'm reusing these IPs, so you get these errors, but that's not a problem. Let me just paste that. And yes. We want to be root. We are going to create the opt K3s folder. We are going to open it. And then we are going to go back to our GitHub repository. Click on small cluster. We want the worker node. And we want the raw content. So edit that. Paste the content inside. And then we need to make it executable. I like to use chmod 775. And let's see. It's executable. Before we run this, we need to put the token that we saved in there. So let's edit it again. We need to replace this token here. With what we have in the notepad. Otherwise, it won't authenticate and it won't allow us to create this node in the same cluster. So now we can save this, Control SX, and now we can run this shell script. Likewise, it's pulling down the binaries from the GitHub repository and doing the installation. This one takes a bit longer than the primary node because it's got to create the node and then register it with the primary node. Now that we have run the script to create the worker node, we go back to the terminal of the master node and we will run kubectl get nodes. And you will now see that we have the master node and the worker node. Going forward, we will use this terminal to complete the Kubernetes workshop. So let's clear the screen. We'll open up the blog, and if you look for chapter 2, we can now create the Nginx deployment. The first thing we need to do is to create the deployment manifest. So we run this command, and then we go here. Copy this whole thing. And save it. Control S, Control X. After we created the deployment manifest, we need to create the service manifest. So we run this command to create the service YAML or manifest. The correct term is manifest. And now we look for it here. It's this one here. Control S, Control X. And then we've got one more manifest that we need to create. We have one more manifest we need to create. This is the Nginx manifest. We run this command and we go back to our documentation and we grab this YAML here. This is the Nginx manifest. Now, some people like to smack all their manifests into a single file. It's a bad idea. It's better to have a few small files where each thing focuses on one thing only. And that way, if you need to change an item on one of the manifests, you don't have this massive document that you need to scroll down to find where to change. It makes it convenient to do that. So let's save this, Control S, Control X. And now we are going to deploy these. We will use the kubectl apply command for each of these. But before we do that, we need to create a namespace. Now let me explain what a namespace is. Think of it like a logical container. So if I create a namespace Nico and a namespace Fred and a namespace Tom, then whatever I put inside Fred or Tom does not interfere with what I put inside Nico. And in this case, we are going to call the namespace Nginx. So the command is kubectl create namespace Nginx, like that. And it says that Nginx was created, which is what we wanted. And if you look carefully, you can see that it looks almost like a folder, namespace /Nginx. So as I said, it's a logical container. Now that we've done that, we will use kubectl apply with various parameters to deploy, to install the service, and to install the Nginx. This one here, service exposed, is actually the Nginx manifest. So this is the command we will run. Let's explain it. Kubectl apply, we are applying a file. -F tells us the details of the file, and that's this one here. And then -- namespace. Always do this when you apply manifests. That way you can control where they go, and it's also very easy when you do the cleanup. And now we can go and verify that this thing was done. And you can see we've created 2 pods. Nginx deployment, both of them are 2 pods. Having done that, now we want to apply the service. So this is very similar to the other one. kubectl apply, we're pointing to a file and we are pointing to the namespace. So you can see it's identical command to that, except that we are using a different file. So let's apply this. Let's clear the screen. Another command that we can run is kubectl get all. So let's do that, all. And now we can see the services URL, as well as we can see the 2 deployments as pods. So now if we take this URL, because we are inside the cluster, we should be able to open it with a curl command, like as if we were in the browser. So let's do that. And there we are. We can see we've connected to our Nginx server's homepage. However, we cannot connect to this outside the cluster. So now we need to do the next. We need to apply the ingress manifest. We cannot access this outside the cluster. In order to be able to do that, we need to apply the ingress manifest, which will allow us to talk to the server outside the cluster. We will run this command to apply the ingress manifest into the same namespace. And this time we should be able to connect to it from the browser. Let's clear the screen. And you can see we can connect to it, and we should also be able to connect to this from the browser. Let's get its port. So let's do that. And there you are. We've now succeeded to open Nginx outside the cluster. We will now go back to our instructions and we will do the second part of the workshop. You may have noticed that we used 3 manifests to deploy Nginx. I would like to spend a minute going through each and explaining what they are and what they do. The deployment manifest is used to create the pods. You will not use this to specify networking. It's just to deploy the application into pods. You do, however, specify replicas, as Kubernetes needs to know how many pods to spawn when deploying this application. After we have deployed the application into pods in the Kubernetes cluster, we need to wire the pods internally to the internal network. Notice internal network. So this is where your service manifest comes in. This is what we used, and this will now also specify internally the port 80. And that's what it does. It wires Kubernetes pods to the Kubernetes cluster. However, we still cannot talk to it from outside. You may have noticed that after we did this, we could do curls from inside, but we could not do anything from the outside. So we needed to deploy an ingress. In other words, the ingress manifest. So the next one here, expose service, this is actually our ingress manifest. You can see here it says type ingress. And the job of this is to expose this pod connected internally to its network externally outside the cluster. It means that after we did this, we were then able to open this in the browser. Without any further ado, let's start the workshop. I'm going to do something I don't normally like to do, and that is to paste from the web page directly and then paste it into the browser. But the reason I'm doing this is so that you can see where it comes from and what we are doing. So you may have seen this command already. This is to get the nodes of the cluster. With this command, we were able to get the nodes inside the cluster. You may have noticed that we created the namespace Nginx when we deployed the three Nginx manifests: the deployment manifest, the service manifest, and the ingress manifest. So if I run kubectl get namespaces, I expect to find that namespace in here. And there it is. But in addition to that, you can see we have others. Now, a word of warning: do not delete these namespaces or you destroy your server. Then we can run kubectl get deployments. In this case, I want to specify the namespace Nginx. You can see there's two deployments. And then we can also say -- all namespaces. So let's run this command. Kubectl get deployments -- all namespaces. And now you can see all the deployments that have been deployed on the server. So here's our Nginx deployment. And then you can see that we also have the traffic load balancer. This comes when you install K3s Kubernetes, which is ideal for running in Proxmox. Let's clear the screen, and apart from getting the deployment, we can also get pods. So let's run this command. And you can see we have two pods because that's what we specified in our deployment manifest. Two replicas. I'll show you that quickly. So here are the two replicas specified in the deployment manifest. And you can also run the same with all namespaces. I'm not going to do that. You will notice all these commands: get deployments, get pods, get services. You can either specify a namespace or you can specify all namespaces. And likewise, we can do the same with endpoints, but we are interested in the Nginx endpoints. So let's copy this, paste it in here. And you can see we have got two endpoints. These are the IP addresses: 10.42.0.10 port 80 and 10.42.0.9 port 80. You will notice that 42 tells us that it's on the same server, and that is correct. I deliberately switched off the other node so that we could be able to show you this. And this endpoint can only be connected to internally, as we demonstrated earlier. As you saw, we had two replicas. So now what we're going to do is we are going to run the get all, just to show you that. So here's the two replicas, and here are the two pods. The next thing we wanted to do is to describe it. Please note there's a mistake in here. It's missing the namespace at the end of this command. You always need to specify the namespace to find the object in the Kubernetes cluster. So let us go and run this again. Get pods. and then describe pods. And notice I've put the namespace here. -N is also an abbreviation for namespace. And now here you can see we get a lot of information about this pod. Right, let's clear the screen. I'll try to update my documentation after this video, but at least you know what the problem is. So the next one now is kubectl logs and then the pod name. So let's run the similar command. This is logs. So this should give us a log. Nothing has happened, so it should be empty. It is. But at least we didn't get an error message. That's important. So that's fine. That's how you access logs. In order to debug our pods, occasionally we need to connect inside them and run bash commands. So to do that, we have a command very similar to Docker. It's kubectl exec-it. This is identical to the command in Docker. What it's going to do is it's going to open up a terminal and it's going to be a bash terminal. So let's try and run this. And then let's just put the last part in. So this is the command we want to run. And you can see I'm now connected inside the terminal. So I can run Linux commands. Who am I? And it should tell me that I am root. And we can exit. We trust you found this useful. Please give us a like. Please subscribe to our channel as we haven't reached our target yet. And now we will greet you in 4 languages. And if you want us to greet you in your language next time, please leave us a comment and tell us what language you speak. And with that we say, baie dankie tot ziens. Grazie mille ami, ciao. Yasu sinaderfe. Domo arigato tomodachi. Sayonara.